Spent fuel challenges mass E-energy equivalence. Microscopic analysis of spent nuclear fuel reveals physical evidence that challenges conventional mass E-energy equivalence by supporting the exploding mass defect hypothesis and the microexplosion hypothesis. These observations suggest that mass defects in nuclear fission are not smoothly converted into energy, but rather are explosively transformed into an ultrafine, ether-like substance, producing unique microstructural damage patterns within the fuel. This alternative interpretation offers an empirical challenge to Einstein's framework and opens new directions in nuclear physics research. Linked in YouTube +2. Microscopic observations. Advanced imaging methods such as Transmission Electron Microscopy, TEM, and Scanning Electron Microscopy, SEM, have been employed to study spent nuclear fuel. This alternative interpretation offers an empirical challenge to Einstein's features and opens new directions radial microcracks research, which radiate outward from central points in the fuel, resembling the aftermath of explosive events rather than typical thermal stress or swelling. Amorphous zones, where the crystal lattice of the nuclear material is abruptly destroyed, indicating violent, localized energy release. Bubble-like voids and nanostructural anomalies, which are more consistent with rapid, blast-like shocks than gradual expansion or gas migration. YouTube +2 LinkedIn. These physical signatures align more closely with the microexplosion hypothesis, proposing that missing mass defect, manifests as discrete, high-energy blasts at the micro or nanoscale within the fuel matrix. Theoretical implications. The exploding mass defect hypothesis, attributed to Joseph George and others, reinterprets the fate of the missing mass in fission. Instead of a smooth transformation into energy this theory posits that the mass defect is explosively converted into an undetected medium, potentially an ether-like fine matter, which can be traced through observable shockwave signatures and microstructural disruptions. YouTube +1 LinkedIn +3. Aspect. Standard physics. E equals mc². Exploding mass defect hypothesis. Mass defect fate. Direct. Experimental support. Empirical studies relying on high-resolution analysis of spent fuel show that certain microstructures cannot be fully explained by conventional models of heat transfer, swelling, or diffusion from fission product migration. Instead, the recurring patterns, radial cracks, amorphous regions, and nanorad voids suggest sudden and intense force application, consistent with microexplosive releases linked to mass defect transformation. These findings encourage a reevaluation of foundational nuclear physics principles and present a direct challenge to the universal validity of mass E-energy equivalence in nuclear reactions. YouTube +2 LinkedIn. Conclusion. Microscopic forensic analysis of spent nuclear fuel provides compelling evidence for the exploding mass defect hypothesis and microexplosion hypothesis. The unique, blast-like damage patterns observed in spent nuclear fuel challenge the sufficiency of Einstein's mass E-energy equivalence, suggesting that at least some nuclear reactions involve explosive transformation of mass defect into previously undetected forms of matter. This empirical approach may reshape fundamental nuclear physics assumptions and inspire future research into alternative energy transformation mechanisms. Link. Spent. Microscopic analysis of spent nuclear fuel reveals physical evidence that challenges conventional mass E-energy equivalence by supporting the exploding mass defect hypothesis and the microexplosion hypothesis. Conventional mass E-energy interpretation and the exploding mass defect hypothesis propose fundamentally different mechanisms for how mass disappears and energy emerges in nuclear reactions. The conventional view holds that mass defect converts smoothly to measurable energy, while the exploding mass defect model suggests an explosive transformation into ultrafine matter, Altering the Understanding of Nuclear Energy Release. Wikipedia +3 YouTube +1. Conventional mass energy equivalence. Based on Einstein's principle, the loss of mass, known as mass defect, in nuclear reactions is directly converted to energy, such as heat, radiation, and kinetic energy of fragments. Fisable +5. This relationship is fundamental across physics and underlies nuclear power generation, fission, fusion processes, and phenomena like stellar energy. Mass and energy are considered interchangeable, with all changes traceable to this conversion. Microscopic evidence in conventional models points to smooth, predictable thermal and mechanical effects, swelling, diffusion, and continuous phase changes. Vedanta +1. Exploding Mass Defect Hypothesis. Argues that the mass defect does not become energy directly, but explosively produces an ultrafine, space-filling matter, potentially analogous to historical notions of ether. Linked in +1 YouTube +1. Nuclear energy release is seen as the result of rapid microexplosions, with reaction fragments propelled spent fuel challenges mass energy equivalence. Microscopic analysis of spent nuclear fuel reveals physical evidence that challenges conventional mass energy equivalence by supporting the exploding mass defect hypothesis and the microexplosion hypothesis. These observations suggest that mass defects in nuclear fission are not smoothly converted into energy, but rather are explosively transformed into an ultrafine, ether-like substance, producing unique microstructural damage patterns within the fuel. This alternative interpretation offers an empirical challenge to Einstein's framework and opens new directions in nuclear physics research. Linked in YouTube +2. Microscopic observations. Advanced imaging methods such as transmission electron microscopy, TEM, and scanning electron microscopy, SEM, have been employed to study spent nuclear fuel. This alternative interpretation offers an empirical challenge to Einstein's framework and opens new directions. Radial